Welcome to the Elemental Journey series. Today we are going to talk about calibration of XRF. In the last episode, I mentioned that XRF is not an absolute analytical technique. So what does that mean and why we need a calibration? Today I'm here with my colleague Lieven. Hi Lieven.
Hi Qiaona.
Could you please introduce a bit the principle of XRF and also the calibration of XRF?
Yeah, I'll do my best. Yeah.
Thank you.
So as we mentioned last time, XRF is not an absolute technique. It's a comparison technique. So it compares intensities from standards that we measure with intensities of your own unknown samples. That's a comparison. So therefore, you need to have an instrument that is calibrated for certain application. There are two different ways to calibrate your instrument or do analysis. First one is the conventional way with a set of standards where you know the elemental composition, you know elements, concentration, you know everything, let's say cement. There's another way, and that is more like a screening tool, can also be used on our XRF instruments, and that is when you don't have those standards, or those standards are not available to buy. Then you can use some kind of a screening tool for screening the elements that are in your sample, at least as an indication. So those are the two different ways, conventional and unknown screening. So when you set up a calibration, you need a set of standards that represent your unknown samples. So if it's cement or if it's iron ore or polymer or pharma, it can be anything, but the standards have to be representing your unknown sample. You have a suitcase of standards. You prepare the samples either as a loose powder or as pressing the powder or fusing the powder, or the standards can also be liquids like oils and fuels. And you measure those standards in your instrument, XRF instrument, that's the course we're talking about, XRF. And then after the measurement of all those standards, you build up your calibration. So you, for each element, you have a calibration line.
Okay.
And that represents your intensities versus the concentrations. So that means your instrument is calibrated for those type of samples. Now, when you have an unknown sample, then you measure the unknown sample in the exact same way as you measured your standards. So you do the same sample preparation. If it was loose powder or pressed powder, you do it the same way.
Okay.
And because that's the best way to compare intensities with each other. So you measure the sample in the same way, also in the same instrument, and then with the, of course, with the software and the calibrations, you obtain results for that unknown sample.
Okay.
So once your instrument is calibrated, XRF method is rather simple because you have your unknown sample, you push your button, you type in the name, you select where it is in the sample changer, and then you say start the measurement. And after a few minutes, maximum half an hour, you have your result. That's how simple it is.
Simple.
Yeah. So there are benefits of both. So when you have the conventional calibration, you have the benefit that those elements of interest, they will be quantified and you get results.
Okay.
Of course, the disadvantage is you need to have standards that are in the similar range of the unknown sample. Now going to the standardless screening, when you don't have those standards available, you can also obtain, we call it omni analysis. You can measure any type of sample. You don't have to have the standards, As long as the sample fits in your XRF spectrometer, you can analyze it. Then after 10 minutes, 20 minutes, you get the result.
Yeah.
And here the result is different because the instrument together with the software will report those elements that are found in the sample. So sometimes you might get more elements in your sample than you expect,
Okay.
but at least you get a rough concentration. The disadvantage is that, as I said, it's a rough concentration, it's an indication. Is it 50 ppm, is it 70 ppm, 100 ppm, roughly.
Yeah.
But at least you know what are the elements in your sample.
Okay.
So that's advantage, disadvantage. And most of the time, users have their own calibrations and also Omnium as a screening tool for other samples,
Yeah.
and can be placed on the same instrument. So that was a little bit about the differences in setting up calibrations, conventional and screening method.
That sounds really clear to me. But do you know, Lieven, that actually the XRF spectrometer is not the only factor that influence our final result. Sample preparation and also the quality of calibration standards are also very critical. And that's why at Panalytical, we have this unique product portfolio which which includes sample preparation and synthetic standards. So in the coming episode, we will talking about sample preparation and also some featured application solutions using our synthetic standards.
Good
Thank
idea.
you, Lieven.
You're welcome.